Question number 18 says it gives us a graph of sine and cos, and it gives us 1 point, and it wants us to determine 4 other points with the same y-coordinate. So I'm going to start with A, which is our sine graph, and I'm just going to draw in the line that represents the same y-coordinate. So we want to find out this coordinate here, this coordinate here, this coordinate here, and this coordinate here. And those points we're going to find by the use of symmetry. So one way to do this is we can take a look at the symmetry of that coordinate here. And if we draw the line at pi over 2 or 90 degrees, we can see that if I go 45 degrees or pi over 4 to the right, I'm at 3 pi over 4. If I go to the left, I'm at pi over 4. So that point there is going to be pi over 4. And we're going to call this point theta 1, and we're going to call this point theta 2. And within one period, we're going to have these repetitions that are based on symmetry. Now, this symmetry could be from the middle. We can also look at the symmetry slightly differently, and we can find this symmetry from pi going backwards and from 0 going forwards. So if I go backwards from pi, I'm going to go minus pi over 4. And so I just go in the opposite direction, plus pi over 4, to get to that point there. So we can use a symmetry not from the middle, but from the outside in. And that's actually where there's a formula for this. And the formula is going to be based on the outside in symmetry. Now, to get the other points, I'm going to do this in a different color. These are just repetitions. So if I go from here to here, that's just the same position on a different period. And so we just need to add 2 pi to get that coordinate. So if I start at pi over 4, I'm going to end up at, that's going to be 9 pi over 4. I can also go back to here. So these are just repetitions of each other. This one here, this one here, and this one here, they're all just repetitions of the same angle. This one I can just go backwards 2 pi to negative 7 pi over 4. The other one here is also repetition, but it's a repetition of the 3 pi over 4 angle. So I can go backwards from here, and again, that's just the same position on a different period, so that's going to be minus 2 pi. So this angle here is related to the theta 1 that I've drawn here, and it is going to be 3 pi over 4 minus 2 pi. That's going to give me negative 5 pi over 4. So those are the 4 positions on that graph. And we can do the same thing with the cosine. So here we have 30 degrees or pi over 6. And as I draw in the line, the same y-coordinate here, I can see that it crosses at this point here. That would represent the symmetrical point, or this point here, this point here, and this point here. So again, I can use the symmetry to get the other points. I'm going to call this theta 1. The theta 2 over here, we can use the symmetry across 0. So this is plus pi over 6. This is going to be equal to negative pi over 6. I can also use a symmetry from 2 pi. So it goes from 0, positive 2 pi over 6. From 2 pi, it goes backwards, minus pi over 6. So this coordinate here is related to the theta 2 coordinate, which I'm going to actually do in a different color. I'm going to do those ones in blue. And that this because we went backwards pi over 6 from 2 pi, it's going to be 11 pi over 6. And those 3 blue angles are actually related to each other. The red angle, theta 1, which we started with pi over 6, and the red angle over here, this one again is just the same angle in a different period. It's in the same position, but in the next period, so it's just going to differ by plus 2 pi. So that one was pi over 6 plus 2 pi. That position there works out to be 13 pi over 6. So we find one angle using symmetry, and we find the other angles by just using the period. There's going to be one other angle that's related to it in the same period based on symmetry, and then we find the other angles based on repetitions of the period. Now again, for this blue angle for theta 1 and the blue angle here, 11 pi over 6, these ones are actually the ones that we would calculate using the formula. So the formula is actually an outside-in formula instead of using the middle line and going inside out to the symmetrical points. So you could do it either way, but when we end up seeing the formula will represent an outside-in repetition, or sorry, not a repetition, but outside-in theta 2 formula.